All right.
What's your favorite teacher eat?
Okay.
Like, where are all your students?
All my students are gone.
I'm
So sorry.
No, that's okay.
Okay, we're all gonna sit in the back apparently today.
You're welcome to come sit next to me.
You can move. All right, so we're gonna talk about, last time we talked about, I don't want that to,
Sexual immorality, you taking the class.
hey, Liz, the video's recording.
Oh.
Okay.
You have to restart it.
You should read it, that's fine. Okay. That's rotated now. This is bothering me so much. Okay, we are going to talk through how to undo the derivatives we talked about on Thursday. So you can do this in a U substitution like way, except we've got the A and the U, and that tends to be a little more complicated. So it honestly tends to be better and faster if you can recognize the pattern of the derivative in our integrand. So if you can recognize the pattern and realize that the integral is going to be our arc-trig function. Where's the back button? There we go. The inverse trig function. So like arc sine, arc cosine, arc tangent. Remember, we don't really focus on arc cosine so much. It's more arc sine and arc tangent. Okay, but you want to be able to recognize that. So we're going to want to have those arc sine and arc tangent derivatives memorized. If you haven't memorized them yet, you're definitely going to want to memorize them for our quiz later this week.
Is that still Wednesday or is it Thursday?
Currently, it's still Wednesday,
Okay.
but there's a high probability that I'll switch Wednesday and Thursday's schedule. But currently, it's still Wednesday.
What's the quiz over?
5-4 to 5-7.
Okay.
Why don't we do 5-7 or 5-7-6-1, whatever, tomorrow? Have a
6-1
review
is
day.
tomorrow.
Oh, okay, and then we have a review day on Wednesday?
No, if we're gonna put the quiz on Thursday, I'll flip Wednesday and Thursday. So we'll do 6-1 on Wednesday. So 6-1 is over the course of 2 days.
Oh.
So we'd either do it Tuesday, Wednesday, and then quiz Thursday. Okay. All right. So we've got the integral of du over the square root of a squared minus u squared. Do you remember which trig function gave us this as its derivative?
Isn't that
that's-
sine, arc sine?
Yeah, so this is going to be arc sine. There we go. Arc sine of u over a plus c.
We have a video tomorrow.
You do have a video to watch tomorrow. It's fine. It's like 12 minutes long, and there's no question. 12.
We're getting that time.
12. And there's no question. So you get 10 out of 10 as long as you watch it.
Okay.
Wait, so we have to watch this? Sorry.
Okay. This video is for the people who are not here, which is the vast majority of them. There is a chapter. If you don't want to sit in the front all by yourself, you can move. There is a 6-1 video that you need to watch for tomorrow, which I will talk about later. We need to talk through this though. All right, so du over the square root of a squared minus u squared, that is our derivative of arc sine of u over a. So the integral of du over the square root of a squared
Isn't that arctangent?
minus u squared is arc sine. So the next one, the integral of du times a over a squared plus u squared is what, Liz?
Arctangent.
Arctangent of
You
what?
heard that? Everybody who skipped class.
Of what? Arctangent of what?
U over A plus C.
Of u over a plus c. So you can try and do a u substitution for these, but it is honestly going to be faster and more beneficial if you recognize the derivative pattern. So if you say that derivative looks like the derivative of arc sine, or that derivative looks like the derivative of arctangent. Now I'm gonna explain through a thought process that I want you to go through every time you see a quotient. Because we've dealt with quotients a couple different times. We had quotients that became the natural log when we did the antiderivative. We had quotients that we would flip up and make them raised to the -1 power, -7th power, or -9th power, and then it would be a u substitution, or Timmy messed up the chain rule. And now we have these quotients here with the arc sine and the arc tangent. So when you see a quotient, there is a thought process that I want you to go through to eliminate or to determine what sort of antiderivative we're going to look at. All right, so the first one you always want to look at is you want to say, is this going to be a natural log question? If I have a quotient and I'm taking the integral of a quotient and it's going to be a natural log, do you remember what we're going to look for between the numerator and the denominator?
Oh, the derivative of the denominator and the numerator.
I want the derivative of my denominator to be my numerator. So I want the numerator to be equal to the d dx of the denominator. So that's the first thing I want to look at. So for number 1 here, when I'm looking at the integral of 1 over the square root of 4 minus x squared dx, so wherever you would like today, is my denominator's derivative the numerator? For the number 1 here. No, what's the denominator's derivative going to be?
1/2 squared.
Yeah, it's going to be 1/2 4 minus x squared to the negative 1/2 times negative 2x. And that is nowhere near the numerator, is it? No. So this is not my natural log question. This is not going to be a natural log question. After you check if it's going to be a natural log problem, because the reason why we're doing this, right now we're in the 5-7 section, so most likely our questions are going to be an arctangent, an arcsine, or whatever. But on your test next week, Thursday, it's not going to be like, this question comes from 5-7, and this question comes from 5-3, and this question comes from 5-4. Next week, Thursday.
Oh my word.
It's a week and 3 days away.
Can you do a cursive Q?
Only like 2 weeks from my last
All right. So first thing you want to try is it a natural log question? The second thing you want to look at is it one of the flip-up questions? Is it one of the ones where I'm going to bring my denominator up and raise it to the negative power? So if I do that, this question now becomes the integral of 4 minus x squared to the negative 1/2 dx. And if I do that, I want to look at the inside function's derivative. I want to look at what the derivative of the inside function is, and I want that to be the other factor. This is what I would want. Do I have that here? Is the derivative of my inside function, that what would be negative 2x, do I have another factor of negative 2x? No. If it was just negative 2, that's okay, right? Because I can adjust by that. Like if this was 4 minus 2x. Anywhere you'd like to sit today, since there's so few of us. Is this going to be one of the questions where I do my flip up? Probably not. I don't have that other factor there. So what I'm going to do then is my third option is I'm going to look for either it being arcsine or arctangent. And then I'm going to look to see, can I find the derivatives pattern for either arcsine or arctangent? So if I look at this equation here, this function, 1 over the square root of 4 minus x squared, does that look more like an arcsine derivative or an arctangent derivative?
More like an arcsine.
Arcsine. And what tells you it looks like an arcsine? There are two things.
The square root.
The square root is one of them.
And
It's not negative.
And well, the negative would make it arc cosine.
Right.
Yes. Yes. And then there's one other thing, though, in the denominator that would distinguish it from the arctangent.
yeah.
It's a minus sign instead of a plus sign, right? So we're subtracting instead of adding. So those are the two things. So here we have an arcsine problem. So what I want to do is after I figure out what sort of integral problem it is, I want to go and I want to make my, I want to identify what my u is and what my a is and then what my u prime is.
Finding the pattern would be easier than doing U substitution.
Yeah, so this isn't a u substitution so much as it is finding the pattern. Because remember, I want to figure out what goes as for my u and my a in the pattern.
Okay.
Yes. So this is where the fact that we use u and u substitution and u in the arcsine and arctangent is slightly confusing.
Got it.
No, but we want to identify this. So we're going to look here. We're going to say, okay, what has to be my u and what has to be my a?
X
X
and 2.
and 2. Are we okay with x and 2 as u and a?
Yes.
So a squared is 4, so a has to be 2. U squared is x, or excuse me, u squared is x squared, so u has to be x. So u prime is going to be 1. And what I need to do now is I need to check and make sure it actually follows my pattern. I want the numerator to be du, or u prime. Is my numerator u prime?
Yes.
All right, so I don't have to do any adjustments. So I can just say this right here is arcsine of u over a, so x over 2 plus c. Oops. But this thought process over here, this is what I want you to go through on a quiz or a test every time you have a quotient. Because not every problem is going to be an arcsine or an arctangent. Just because there's a square root in the denominator does not automatically mean it's arcsine. Because what would happen if I changed the problem and I made it the integral of x over the square root of 4 minus x squared dx? Just have one little switch and I throw an x in there. Okay, go through the process. Would this be the natural log? No, same issue. The denominator's derivative is a lot more complicated than just an x. If I do a flip up, what's the derivative of my inside function, of the 4 minus x squared? What's the derivative of that? Welcome, ladies. Have a seat. What's the derivative of my inside function?
Negative.
Negative 2x. Can I adjust the numerator here to make that a negative 2x? Yeah, I just have a negative 1/2 out in front. So I get a new problem here of this is now negative 1/2 times the integral of negative 2x times 4 minus x squared to the negative 1/2 dx. And now I can do my integral. And I would do my power rule on that 4 minus x squared. So having just a slight adjustment of now there's an x in my numerator instead of a 1 no longer makes it arcsine or arctangent. So just because there's a square root in your denominator does not automatically mean it's arcsine. So I really want you to go through this thought process here. First, if it's a natural log, numerator has to be the derivative of the denominator, or some adjustment, some constant multiple away from it. The flip up, you want the inside function's derivative to be your other factor or some constant multiple away from it. If neither of those work, then look for arcsine or arctangent. So we're going to go through the process again with number 2. Go through the same process. I'm not going to write it out because you can write it all out or you can think it through. Either one, whichever one is better for you. But I want to look at this here and I want to first think, is this going to be a natural log question?
No.
What's the derivative of your denominator? 18x. Can I adjust a 23 into an 18x?
No.
No, I can adjust it into an 18, but not to an 18x. So it's not a natural log. So natural log is a no.
It's on the square root.
It's not a square root. That's not necessarily an issue, though, is it?
No, I'm talking to Cam.
Oh, you're talking to Camden. Okay. It's probably the one next to him. Is this a flip-up question? What's the derivative of your inside function going to be? If I were to flip this up, what would happen? If I did a flip up here, this would become the integral of 23 times 4 plus 9x squared to the negative first dx. There are 2 issues with it being a flip up question.
-1, and so
My
turn into the 0 power.
Yeah, if I try to do the power rule on this, I would have the 0 exponent, which means I would have had to divide by 0, which is a big no-no. And then my other issue is, what's the derivative on the inside here?
18x.
be 18x. I also don't have another x to cancel out with that 18x. So there's two issues here. One is that I would be dividing by 0. The other is that it would be, I don't have an extra factor of x that I would need. So it's neither of these. So I'm going to look in and say, okay, is it arc sine or arc tangent? And I want to look at the patterns. Which one does this fit better, arc sine or arc tangent? Arc tangent. So I'm going to go through and I'm going to say, okay, what's u? 3x, because I need u squared to equal 9x squared. So u prime is 3. And what's a? 2. Again, it's super easy to pull out the 4 and say a is 4. For some reason, we're usually okay with u squared being, with the variables squared and all that, we're usually okay with that, but the constant of a, remember that's also being squared, so it's the square root of 4, so it's 2. All right, what I'm going to do is I'm going to pull the 23 out in front because I think it's going to be a lot easier to do my adjustment if I just have a 1 in my numerator. So here's my problem. I'm going to pull the 23 out. I'm going to pull that constant multiple out. What do I want to have in my numerator if this is going to be arc tangent? I need 6. I need a u prime. I want my numerator to be a times u prime. So I want this to be a 6. So times 1/6 or divide by 6 outside. So you can make a 23 into 6. If you leave the 23 in the numerator, you can make it into a 6 by multiplying by 23/6. But for some reason, that just confuses me. So it's always easier for me to pull the constant multiple out and then do my adjustment. Because I don't have to worry about which fraction I need to do, which one should be in the numerator or the denominator. I just say, okay, multiply by 6 inside, divide by 6 outside. And now the 23 over 6, that just comes down out in front. And we said it was an arc tangent of u over a, so 3x over 2 plus c. Okay. How are we feeling? Feeling good? Really good? All right, so this process here, this quotient process, every time we see an integral of a quotient, I want you to think through this in this order. Because the majority of the time they're going to be natural logs. After that, flip up. And then after that, it's going to be arc sine or arc tangent. Okay. All right, so if we go to the next page, what I'm going to do is, because I want to talk about number 5 and 6 first, we're going to go to 5 and 6, and then I don't think we'll have time to come back. I'll put the answers for 3 and 4 up online so you can try those on your own and then check. But we're going to do number 5, because what's wrong with number 5? It's ugly. Okay, let's go through our process. Natural log first. We'll try our natural log first. Natural log. Hi, Jackson.
Jackson.
Find a seat. We started with 4, so we all just... 6. Start with 6. All right, natural log. What do I need if it's going to be a natural log problem?
It needs to have numerator the derivative of the denominator.
All right, so numerator has to be the derivative of the denominator. Is there any way 3 is the derivative of the square root of negative x squared plus 4x plus 77?
Not quite.
No. So no. Not a natural log. What about a flip-up question?
Probably not.
Okay, flip-up question. That denominator would get flipped up, so we would get a integral of 3 times negative x squared plus 4x plus 77 to the negative 1/2 dx. And now I'm going to look at just the inside here. Is the derivative of my inside the other factor? No, I don't have any other x's, so it's not a flip-up. So that means it has to be either arc sine or arc tangent. Now, the problem here is it doesn't really look like either of them.
The square root resembles.
But the square root is what gives it away. Arc tangent does not have a square root. Arc sine does. So even though what's inside the square root, the argument of the square root doesn't look right. It has a square root, so it's going to be an arc tangent problem, or an arc sine problem. It's an arc sine problem. What we need to do is we need to think back to Algebra 2, and we need to do something that I know you all love. We have to complete the square. I did. I know. It is a dirty phrase. You don't like it. But we have to complete the square. We want to take that quadratic and make it into the sum of two perfect squares. Because that's what we want. We want an a squared plus u squared. Or, excuse me, we want an a squared minus u squared since we're in an arc sine problem here. So what we need to do is we need to complete the square. Now, think back 2 years. I know it's been a while, but we can do this. What we're going to do is we are going to just pull this quadratic out first. We're going to complete the square outside of the integral problem, like separated from it, and then we'll go back and plug it in. Sort of like how we did our long division or our synthetic division. We did that off by itself, and then we came back and said, okay, here's our new problem. That's much nicer to deal with. So we're going to do our complete the square. Does anybody remember what the coefficient on x squared has to be to complete the square? Positive 1. So what I have to do is I have to get rid of that negative. So what I want to do is I want to take my trinomial here and I want to group it so that I have the first two together. And then I want that constant off by itself. But I need to pull my negative out. So just like you pull a negative out of everything, we're just going to factor it out. But I'm only going to factor it out of the first two. Because I don't really care about it coming out of the 77. Because that's separated. So I'm going to group the first two together. Leave that constant out by itself. But I need to pull the negative out. So I've got a negative in parentheses. X squared minus 4x. And then that plus 77. I need to add a strategic 0. I'm going to add something inside of the parentheses, and I'm going to add something outside of the parentheses that create 0. So I'm not changing the problem, but I'm picking numbers strategically so that this becomes a perfect square trinomial. It's 4. Remember, you take that middle term, so that negative 4, cut that in half, and then square it. So I'm going to add 4 on the inside. And I'm going to add 4 on the outside. And this is where it gets tricky. Normally I would subtract, but because we have this negative out in front, this blue 4 here is really a minus 4. So I need to add a 4 out here to counterbalance that. If you are uncertain, you can always redistribute your negative sign and combine like terms, and you should get what you started with. If you are uncertain if it's supposed to be a positive or a negative 4, you can distribute the negative sign and then combine like terms, and you should get your negative x squared plus 4x plus 77. What I have inside of my parentheses is now a perfect square trinomial. That factors into a beautiful x minus 2 quantity squared. Remember, it's always that same b over 2 value. So negative 4 over 2. And now I get a plus 81 as my constant, which is nice because isn't 81 a beautiful perfect square? And x minus 2 squared is a beautiful perfect square as well. So I'm going to take this process that we just did, and I'm going to rewrite my integral. My integral is now, and I'm going to pull the 3 out because it's going to make it easier for me if I pull the 3 out. The square root of 81 minus x minus 2 squared. I also flip-flop the order there. I hope that's okay with you. And don't you see how this fits so much nicer with our arc sine derivative pattern? It does. So now, just like we did before, we can identify what my u is, so u prime, and what my a is. But you do have to go through the process of completing the square. It is algebra. Does not necessarily make it easy, but you have done it before. You can do it again. It's just remembering the process. So in this problem, what is my u? X minus 2. So u prime is 1, which is nice. What's a? 9. For arc sine, do I want u prime in my numerator, or do I want a u prime? I just want u prime. And I have u prime. Now that I pulled the 3 out, I have u prime. So I just get 3 arc sine u over a, so x minus 2 over 9 plus c. How do we feel? We're going to do number 6 together, and then I'll leave 3 and 4. You can do those on your own. I'll put the answer key up later. But we're going to do number 6 together. It's at the top of the next page. Go through the process again. Natural log. Is it going to be a natural log problem? No. Derivative of your denominator is 2x minus 2. Do not have that in my numerator, or any way to adjust to get that in my numerator. Is it going to be a flip-up question? No, because I've got the same issue we did in our second question. If I flip it up, I've got a power of -1, and then I also don't have the inside's derivative as the extra factor. So it's either arc sine or arc tangent.
Looks like
Arc tangent. The lack of a square root, after we go through the first two properties, like is it a natural log or is it a flip-up question, the lack of the square root should say that this will be an arc tangent. Oops. What do I have to do, though, before I can actually do my derivative? Complete the square. Everybody's favorite. This one is a little bit nicer, though, isn't it? Don't have a negative outside to worry about. All right, what do I add after I regroup it on the inside of my parentheses here? 1, because you take half of -2, square that. So half of -2 is -1. Negative square is +1. Now what do I put on the outside? Subtract 1. Remember, you want to add 0. I don't want to change my problem. Just want to change the way it looks. So we're going to add a strategic 0. Just like when you're simplifying a radical. Like when you've got a radical in the denominator, you multiply by a strategic 1. We're going to add a strategic 0. So the parentheses here become x minus 1 squared, and then I get plus 49, which is nice. I'm going to rewrite this as 49 plus x minus 1 squared. So now when I go back and I do my new problem, I'm going to pull the 5 out, and this becomes 1 over 49 plus x minus 1 squared dx. So I can say, all right, what's u? So u prime is nice and 1. What's a? What do I want in my numerator for arc tangent? U prime or a times u prime? So I've got a 1 in my numerator. I want to make that 7. So how do I adjust to put for that 7 there? Divide by 7 on the outside. So I have 5 over 7 arc tangent x minus 1 over 7 plus c. Okay. So I pulled the 5 that was originally in my numerator out front. And so my new numerator is just 1. But for arc tangent, I want my numerator. I want the numerator to be a times u prime. So I want my numerator to be 7. So I had to put a factor of 7 in, and to adjust by that, I needed to divide by 7 on the outside. I'm going to put this video up so you can, if you came in late, you can check. I'm gonna put the answer key for the whichever ones we skipped up as well. Tomorrow, we're starting chapter 6, so you have to have the notes printed, and there is a video for 6-1, 12 minutes long-ish. You can watch it. There's no questions, so if you watch it, you get your full credit. It's about slope fields, and we actually talked about slope fields on the very first day of class.
It's like where it has its own look.
Yeah, and that is due tomorrow.
Quiz on Wednesdays.
That's the current plan. We're gonna see how
test
we
Monday.
feel tomorrow. Test next week, Thursday. Test next week, Thursday.